Okay, we are going to finish up the semester with some things from Chapter 10 relating to analytic geometry. We're going to be studying some curves, conics like parabolas and ellipses and hyperbolas, and some other interesting curves as well. So today, introduction to conics and a look at parabolas. So conics or conic sections are a class of curves that include parabolas, circles, ellipses, and hyperbolas. And we will talk about all of those, what they are exactly, and their properties as we go along in these next few days. But what they all have in common is that they're all curves that you can get if you take a double cone and slice it with a plane. Depending on how you slice it, you get different kinds of curves. And so that's why they're called conic sections or just conics. So if you slice it just the right angle, the curve that you get intersecting the plane with the cone is a parabola. If you slice it right straight across with a horizontal plane, you get a circle. If the plane is tilted somewhat, you get an ellipse. And if the plane is vertical, straight up and down, then the intersection is a curve made up of these two branches that we call a hyperbola. And so what those have in common geometrically is that they're all curves that you get by intersecting a plane with a double cone. But what they have in common algebraically is that they're all graphs of equations that look something like this, that have x squared and or y squared and or xy, and maybe an x term and a y term and a constant term, but nothing more than that. So any equation of this form will get you the graph looking like one of those conics. Or possibly you could get an equation like this where the graph consists of no points or just a single point or something like that. So today we're going to be talking about parabolas. And you've already dealt with parabolas. You should be familiar with them because they're the kind of curve you get when you graph a simple equation like y equals x squared. But you may or may not know this geometric definition of a parabola. A parabola, what makes up the points of a parabola, it's the set of all points that are equally distant from a given point F, called the focus, and a given line L, called the directrix. And that line does not contain the focus point. So here's an example, and I'll give you a link to this if you want to play around with it. Here is a parabola, and then this line running across below the parabola is the directrix. And this point here inside the parabola is the focus of the parabola. And then here we have a point on the parabola. It might be up here, might be down here, might be on this side of the parabola. But no matter where we are on the parabola, what makes it a parabola is that the distance that that point is away from the focus is exactly the same distance as the distance that point is from the directrix. So as we trace this point along the parabola, no matter where we are on the parabola, we're always the same distance from the focus as we are from the directrix. Now this will also let me change where the focus is. So now I move the focus closer to the directrix, but still for every point on the parabola, that point is exactly as far from the focus as it is from the directrix. So what that means is you can start with any point F for the focus, and any line L for the directrix, as long as the focus point is not on the line L. So once you've picked out a focus point and a directrix line, then the parabola that has that focus and that directrix is, by definition, the set of all points P such that the distance from P to F is equal to the distance from P to L. So let's see what that actually gives us in terms of an equation. So in this example, I'm going to pick for my focus the point 3, 0, and I'm going to pick for my directrix the vertical line x equals -3. The focus can be any point. The directrix can be any point, any line, vertical, horizontal, diagonal. Here it's this vertical line x equals -3, and the focus is this point 3, 0. What does that give us for a parabola? Well, for any point on the parabola that has that point for a focus and that line for a directrix, that means that the distance from that point to the focus is equal to the distance from that point to the directrix. So what are those distances? So if we got the point xy here somewhere on the parabola, the distance from that point on the parabola to the focus, using the distance formula, would be the square root of x minus 3 squared plus y minus 0 squared. That's the distance formula, square root of x coordinate minus x coordinate squared plus y coordinate minus y coordinate squared. And the distance from the point on the parabola to the directrix, here it's just right straight across horizontal. To get to the closest point on the directrix, we just go right straight across, we stay at the same y level, but we go from where x is whatever it is here, x, to over here where x is -3. So the distance from here to here is x minus -3. It's how far apart x is from -3. So that would be x minus -3, or the way I've drawn it here, it sure looks like x is greater than -3, but if we didn't want to assume that, we could put absolute value bars around it and say it's just the absolute value of x minus -3, just to get the distance between the x coordinate on the parabola and the x coordinate on the line, which is -3. Okay, so that gives us the equation square root of x minus 3 squared plus y minus 0 squared equals the absolute value of x minus -3. And of course, instead of writing x minus 0, I can just write, or instead of writing y minus 0, I can just write y. And instead of writing x minus -3, I can just write x plus 3. And I can get this square root out of the way by squaring both sides of this equation. So the square root squared just gets rid of that. And now when I multiply things out, x minus 3 squared multiplied out is x squared minus 6x plus 9, plus we got the y squared. If you take x plus 3 and multiply that out, you get x squared plus 6x plus 9. Now what can we do to simplify this equation? Well, there's an x squared on both sides, so I can just subtract x squared on both sides. I can subtract 9 on both sides. I can leave the y squared where it is, but I can get rid of the minus 6x by adding plus 6x to both sides. And after I've done all that, I end up with y squared equals 12x. So it turns out the equation for this particular parabola, with its focus at 3, 0 and its directrix being the line x equals -3, is y squared equals 12x. Notice this includes the point 0, 0. That is the vertex of the parabola. So that is halfway between the focus and the directrix, 3 spaces away in either direction. And then it includes all these other points, but what they all have in common is their y coordinate squared is equal to 12 times their x coordinate. Here I just kind of picked the number 3 just for the sake of an example. If I had picked a different number and then the negative of that number, all the details would have worked out the same, but instead of y squared equaling 4 times 3 times x, I would have had y squared equals 4 times whatever that number is. Here I used p to stand for it. Y squared equals 4px. And here the p is how far the focus is from the vertex. The vertex, remember, was at 0, 0. And it's also how far the directrix is in the opposite direction from the vertex. So y squared equals 4px is a parabola like this that opens to the right. The vertex is at 0, 0. The focus is on the inside of the parabola in the direction it opens, p spaces away from where the vertex is. And the directrix is this vertical line, p spaces in the opposite direction. If we had the same equation but with a negative sign in it, y squared equals negative 4px, that would make the parabola open the opposite direction, to the left. And now the focus is over here, still on the inside of the parabola, p spaces away from the vertex. And the directrix would be over here on the other side of the parabola. And if we interchange the roles of x and y, like x squared equals 4py, then we get a parabola that opens upward. The vertex is still at 0, 0. The focus is still on the inside of the parabola in the direction it's opening, but now that is up. So if we started at the vertex and went up p units, that would be the focus. And if we went down p units, that's where the directrix is. And if we have a negative, then the parabola opens downward instead of upward. So x squared equals negative 4py opens downward like this. And again, the focus is on the inside of the parabola, p units away from the vertex. So what are the focus and directrix of just plain old y equals x squared? Well, you can think of x squared as that's the x squared that was on one side of the equation. On the other side, we just had a plain old y. So the number in front of the y was 1. And if we want 4p to equal 1, p would have to be 1/4. So this would be like x squared equals 4 times 1/4 times y. That means to get to the focus, we would start at the vertex and go up 1/4 of a unit to the point 0, 1/4. And the directrix, we'd start at the vertex and go down 1/4 of a unit, and that would be this horizontal line, y equals negative 1/4. And now here's an example of where I've started with something like x squared equals 4py, but I've replaced x with x minus 2, which shifts everything 2 spaces in the x direction, 2 spaces to the right. And I have replaced y with y minus 1. And that shifts everything 1 space in the y direction, 1 space up. So instead of the vertex being at 0, 0, now the vertex is at the point 2, 1, where x is 2 and y is 1. So in general, for any parabola where the vertex could be any point, hk, the equation can be written x minus h squared equals 4p times y minus k, with possibly a negative sign there if you want it to open down instead of up, or y minus k squared equals 4p times x minus h, again with possibly a minus if you want it to open left instead of right. So we'll come back in part 2 of the video and look at some more specific examples. See you then.